Hello, Charan.
Hello, sir.
Good evening. How are you?
Fine, sir.
Wait. Just let's wait for a minute and then we will start. Okay. Hmm. So, work energy, sorry, circular motion we have completed in the last class, isn't it? So, we will start now. The work energy power. Okay. Right. Let's start now. Okay. So, circular motion, all type of questions, even the vertical circular motion, which is an example of what? The non-uniform circular motion. That also we have discussed, isn't it? In a circular motion there are going to be two type of acceleration, right? Centripetal acceleration and the uh, tangential acceleration. Okay. This is the last question given. Have you solved this one? Where it okay, this is the two cases we have discussed. Okay, chali, let's start with the work energy power now. Okay. Right, so we know what are the forces acting on the particle, and now we are going to discuss about what will be work done by a given force. Okay. So if we want to calculate work done by a given force, so work done depends on what? It depends on the force and displacement of the particle. Okay, work done depends on what? The force and displacement of the particle. And what is the purpose of the work? The purpose of work is to what? Change the energy of the body, okay, or energy of the particle. So whenever we apply force on a particle and the force does some work, then what happened due to that work? Due to the work, the kinetic energy of the particle changes, isn't it? So, how do we calculate the work done? So, work done is what? Whenever we want to calculate, work is dot product of what? Force and displacement. Okay, what is the work done? Work done is the dot product of what? Force and displacement. Dot product means what? It means magnitude of F, magnitude of S, and the cos theta. Theta is what? It is the angle between the force vector and the displacement vector. Like let's say this is the force vector and the displacement of particle happen in this direction, and there is an angle between these two. This angle theta is what? Angle between the force vector and displacement vector. Clear? So force and displacement vector is making how much angle? It is making theta angle with each other. So dot product of F and S, if we are defining, that is magnitude of F, magnitude of S into cos theta. This is the work done calculation for what? If force is constant. Okay. If force is constant and we want to calculate the work done by a constant force, then what we should do? We should just take the dot product of what? The force vector and displacement vector. But always we will not find out what kind of force? A constant force. Sometimes the force we will find out is going to be a variable one, isn't it? So if it is a variable work force, okay, now work done, we have written this method for what? For a constant force. Work done by Variable force. Variable force means what? That force whose either magnitude is changing or direction is changing or both of them are changing. Okay, then that force will be called as what? The variable force. If the force is variable, then what we will do? We will first calculate the work done for a small displacement. So how much we will call it? F dot ds we will call it. And to calculate the total work done, what we should do? We should integrate the F dot ds. Clear? And keep in mind one thing about the work done. Work done is dot product of what? Dot product of force and displacement vector. So dot product of the two vector gives us what kind of quantity? It gives us the scalar quantity. Is that clear? Please tell me. So work done is what? It is a scalar quantity. But work done can be positive, can be negative, or it can be zero also. So what does it mean by positive work done, negative work done, and zero work done? So work done can be what? Can be positive, it can be negative, or it can be zero. So what does it mean by work done is positive? Let's say we calculated and we got work as what? Something positive. What does it mean? It means that kinetic energy of the particle is going to increase. Whenever we are doing positive work on a particle or on a body, what happens? It increases the kinetic energy. And if we do negative work done, then what happens? It decreases the kinetic energy. Okay. So positive work done, what it does? It increases the kinetic energy. Okay, it increases the kinetic energy of the particle. Is that clear? What does it mean by positive work done? It increases the kinetic energy of the particle. Clear? What about the negative work done? If the work done is going to be negative, then what it does? It decreases the kinetic energy of the particle. Okay, decreases the kinetic energy of the particle. And if work done is coming zero, what does it mean? That means no change in kinetic energy. Later we will learn about the relation between the work done and kinetic energy. Okay. Although we have already used that theorem, work energy theorem, remember the vertical circular motion when we were solving, we have used the work and kinetic energy relation. So if the work done by a force is zero, then what it will do? There is no change in kinetic energy of the particle. Clear? So if work done is coming zero, then kinetic energy of the particle is not going to change. Okay. So when the work done will come positive, can you tell me when the work done will be coming positive? So if a force and displacement, okay, like here, if this is the force vector and this is the displacement vector, if this is the angle theta. So if I say theta is lying between 0 to 90 degree, that means the angle between the force and displacement vector, if it is acute, what is the work done will come? Work done will come positive. If theta is lying between 90 degree to 180 degree, that means it is what? Obtuse angle. What is the work done will come? It will come negative. And if theta is exactly equal to 90 degree, what is the work done will come then? Then it will come the zero. Understood? So work done by a force can be positive, can be negative, or it can be zero, depending on what? Depending on how the force is acting and what is the direction of displacement due to the application of the force. So please tell me, do you understand what is the meaning of work done? how do we calculate the work done? So work is done on a particle for what purpose? To change the kinetic energy. Change the kinetic energy means change the speed of the particle or velocity of the particle. We can increase the kinetic energy or we can decrease the kinetic energy depending on what kind of work we are doing. If we are doing positive work, kinetic energy will increase. If we are doing negative work, kinetic energy will decrease. And if we are doing zero work, then what will happen? Kinetic energy will remain unchanged. Is that clear? Please tell me. Clear up to this? And how to calculate the work done? If a force is constant, constant means what? Magnitude constant and direction constant. So if force is constant in magnitude and direction, then what is going to happen? The work done, we can use directly the dot product. If the force is variable, then we should take help of integration to calculate the work done. When it is a positive, negative, and zero work done. So, and what is the meaning of those three type of work done? So positive work done will come if angle between force and displacement vector is what? It's a 90. If it is obtuse, negative will come, and if it is exactly 90 degree. So even though the force is there, है ना, displacement also happened. But if force and displacement are perpendicular to each other, you can check it. It's a dot product, right? The dot product will come zero for the two vectors to be perpendicular to each other. So please tell me up to this part is clear. Now there is another way to find out the work done. Okay, work done or work done calculation can be also done using graphical method. Using what? The graphical method also we can calculate the work done. What is the graphical method to calculate the work done? Sometime what will happen, they will give you a graph between force versus displacement. What graph is given here in the question? The graph given in the question is force, what is the unit? Newton. Displacement, what is the unit? Meter. Okay, and this kind of graph is given to us like this. Now tell me, what is the area representing here? Can you tell me what is the area under the graph represent? Can I say area under the graph will represent F dot ds will represent? Right now. So it means, can I say the area under the graph, which is F dot ds, it gives us the work done. So sometime what will happen, instead of giving you the vector form of force and displacement or magnitude direction form, they will give you the graphical method. Okay, so using the graphical method also we can find out the work done. But only thing we have to be careful here is that when we are writing the area, let's say this is a1, this is a2, and this is what? A3, right? We have done many times, na? We have found out the area. In kinematics also many time we had to find out the area, isn't it? So whenever we are calculating the area, we must think about the sign, isn't it? Because this integration is the area. Area is representing the work done, and work done can be positive or negative. So which area you will take positive and which one you will take negative? So area above the axis we will take it positive, and below the axis we will take it as what? Negative. So can you tell me what is going to be the net work done here? A1 plus A2 plus A3 plus A4 like that. Okay. But when we are going to write these value of A1, A2 and A3, we must not forget about their sign. If A1 is positive, we will put it here positive value. If A2 is negative, we'll put it here negative value. A3 positive, again positive value, we should keep it. So when you are using the graphical method to find out the work done, please keep the area with their sign. Understood this one? Please tell me up to this part is clear. Please tell me, clear up to this? So now let's discuss some examples of how to calculate the work done. Okay. If force is constant, then you don't need to worry about the path. And work done is a path dependent quantity. Work done depends on the path of the path of the particle, but not always. If force is constant, then it is path independent. But if force is variable, then it depends on the path. Understood? If it is a conservative force, path independent. If it is non-conservative force, it depends on the path. Okay. So let's take an example and try to calculate it. Okay. A question is given to us like this. A block of 5 kg is kept on a horizontal surface and we are applying a 50 Newton of force here. Okay. What we are doing, we are applying a 50 Newton of force here, and this angle of application of force with horizontal is what? 37 degree. It's not leaving the contact. Okay. This object is always on the horizontal ground and it does not leave the contact. Okay. They are asking in the question, find find work done by. Can you tell me work done by? Chalo, let's write it. Work done by normal. How many forces are acting on this object? Normal is acting, isn't it? Gravity is acting, and that external force of what? 50 Newton is acting. Okay. So find work done by normal. Next, work done by gravity and external force. Find work done by these three forces from from 0 to t equal to 0. This is the particle location. Okay, now t equal to 0, we started applying the force here, and from t equal to 0 to t equal to 4 second. Do you understand the question? The question asks what? Find the work done by this force from t equal to 0 to t equal to 4 second. Now tell me, can you answer directly that work done by normal is going to be 0? Please tell me. Can you say that? Why? Because if you draw the free body diagram, normal will act like this, mg will act like this, isn't it? And the displacement of particle will happen something like this, isn't it? And after t equal to 4, somewhere here it will reach. This must be we calling as what? The displacement of the particle. So we have to calculate the displacement. But even though if I calculate the displacement, but I can write the work done by normal is 0. Can you tell me the reason why work done by normal is 0? And why work done by gravity also 0? Because normal is acting upward direction, particle displacement horizontal direction. So normal and displacement are what? Going to be perpendicular to each other. So work done by normal is going to be 0. And same thing happened for the gravitation force also. So that's why normal and gravity work done is 0. Now please tell me what is the work done by external isn't. Please calculate it and tell me how much is that coming. Please tell me how much it is coming. How much is coming? Work done by the external force, 50 Newton force. Tell me Lokesh. Tell me Charan.
Sir,
Yeah, tell me how much is the work done by that external force coming? We are calculating now that one. Work done by normal is coming zero, right? Gravity also zero. But what about the work done by that external force? How much is that coming? Should we calculate what is the displacement? Tell me.
Yes,
To
sir.
calculate the work done by that external agent, the force is already known, right? If I want to complete the work done, we need to know what is the displacement of the particle. How do I calculate the displacement? See, if I want to calculate the displacement, see that if you look at the free body diagram of this object, normal is like this, mg is like this. This is the 50 Newton force. If I take the component, this component will come 50 cos 37 and other component will come 50 sine 37. Look at that, normal plus 50 sine 37, that will be balancing the 50. We got the normal force. Okay. Now, what about the 50 cos 37? So 50 cos 37 will provide us the acceleration. So what is going to be 50 cos 37 should be equal to mass into acceleration. So 50 cos 37 is 4 by 5. That should be equal to 5 into a. So we are getting the acceleration as 8 meter per second square. Right? 10 into 440 by 5. That means this is the acceleration of the block. So, and there is no friction given in this question. So 0 to 4 second, what will be the displacement from 0 to 4 second? The starting from rest, the ut plus half, acceleration is 8, time is 4 square. So how much we are getting? 16 into 4, 64 meter we got it. Now, now the third force, that work done by that external force, how much it will come? The force is 50 Newton, displacement is 64 meter, and angle between force and displacement is cos 37, because the force is always applied at what angle? 37 degree to the horizontal. So that's why the force and displacement is always making how much angle? 37 degree angle. So force displacement cos 37 is 4 by 5. So we are getting a 5, that means that will be 10, and a 4 into 4 16, 24 and 1 25, 2560 joule. That is what, and this work done is what? Positive. That means after t equal to 4 second, you will see the velocity of this particle must have got changed. Initially the velocity is 0, and t equal to 4 second, you will find the velocity of this particle to be something different. Can you tell me what will be velocity of the particle at t equal to 4? So there are two ways you can solve it. What will be velocity? Can you apply it? U plus a into t, 32 meter per second, right? You can also find out the velocity at t equal to 4 using work energy theorem. Final kinetic energy half m into v square minus initial kinetic energy 0, and change in kinetic. I will discuss this one again, don't worry. Just I took this example and I thought let's discuss this another thing about this question. Final kinetic energy minus initial kinetic energy should be equal to work done. What is the total work done we have calculated? 2560 joule. If I calculate the velocity from here, I will get exactly 32 meter per second. So sometime what happens, it is advantageous for us to uh, use the work energy theorem to calculate the velocity or speed after some other time. Okay, sometime we can use the equation of motion also, sometime work energy theorem. So please tell me, understood how to calculate the work done? Please tell me, understand this one? So this is how we are going to calculate the work done. Clear? Let's discuss one more example of work done calculation. Okay. In this example, what is given to us? A force is given to us. The force is given as 3 I cap plus 4 j cap plus 2 k cap. This is the force acting on the particle given in the vector form. And particle moves from 2 comma 1 comma 3 to 4 comma 5 comma 3, or let's say 4 comma 5 comma 4. Okay, a force is acting like this, and because of this force, this force is constant, na? Check it, it's a constant force, na? Not a variable force. So this force is given as what? A constant force, and particle moves from initial point to final point. Now in the question they are asking, find work done, okay, by the applied force. Find work done by the applied force. Understood? So please tell me how much is that going to be? Simple one, okay na? Force is given and particle initial and final position is given to us. So from the initial and final position, can we find out what is going to be the displacement of the particle? And as you look at the force, it is a constant force. The work done can be directly calculated using what? Using the dot product method, isn't it? So please tell me how much is that coming? Tell me how much it will come. So in this question, if you see that the force vector is directly given to us 3 I cap plus 4 j cap plus 2 k cap, and displacement vector, if I want to write it, displacement vector is what? Final position minus initial position. And is it question gave that this is my initial point and is it my final point? The final position is 4 comma 5 comma 4. In the vector form, it will be 4 I cap plus 5 j cap plus 4 k cap minus initial position is what? 2 I cap plus j cap plus 3 k cap, right? Just find out the difference in the vector. How do we take the difference of the vector? The difference of vector means they are component wise, isn't it? So if you take the difference component wise, how much it will come? 4 I cap minus 2 I cap. 2 I cap will come. 5 minus 1, 4 j cap will come. 4 minus 3, k cap will come. So now we know what is our force vector and what is the displacement vector. And as force is a constant vector, so I don't need to worry about the integration thing, है ना? We can directly start using what? F dot S. So what is the force vector? 3 I cap plus 4 j cap plus 2 k cap dot. What is the displacement vector? 2 I cap plus 4 j cap plus k cap. And if you look at that, you will say, sir, where is the force magnitude? What is the displacement magnitude? What is the angle between them? So here, instead of using the magnitude and angle form of dot product, what I will do? I will use the component form of dot product. Okay, what is the component form? So whenever we take the dot product, I cap component will be multiplied by I cap. So how much we will get it? 3 into 2 plus. Next, j cap component, 4 into 4 plus k cap and k cap, 2 into 1. Right? So what are we getting? 6 plus 16 plus 2. 24 joule we are getting our understood. If I ask you what is the final velocity, you can directly use it what? Directly use it change in kinetic energy equal to work done. For that, I should give you the mass of the particle also. Okay, now because to apply the work energy theorem, you need the particle mass also. Okay, understood? Please tell me, understand this one? Next, in this question, what is given to us something. We are till now we have taken the force we have taken in the example, right? Let's take an example of the variable force. Okay, there are many cases where you will get the variable force whose work done you need to calculate. Okay, so let's discuss the force of a variable force. Okay, a question gave the force is given 2 plus 4x is given to us. Now you see that is it a constant force or variable force? So you will see that this is a variable force, isn't it? This force is what? It is a variable force. Why? Because this force changes as the particle move in the x direction, isn't it? The force is given as 2 plus 4x. Here only force is variable in one direction. Which direction? Along the x-axis only, okay? The force is given 2 plus 4x. Find find work done by the force to move it from x equal to 2 to x equal to 6. Understood? What will be the work done by this force if the particle moved from where to where? X equal to 2 to x equal to 6. Please tell me, use the integration now, isn't it? Should I use the integration here to calculate the work done? And the reason is what? The reason is here the force is variable nature, right? Force is changing as per the x direction. So that's why if force is variable in nature, what we should do? We should find out the work done using the integration. Okay. So please tell me how much is that coming? How much is that coming? Please tell me. What you will do? You will write it dw equal to f dot ds. And here the only variable is what? The x. So we are writing f dot dx. Okay. And we will integrate it to get the total work done. So what is the force vector? 2 plus 4x dx, and integration of x will happen from where to where? Lower limit 2, upper limit 6. Integrate it. 2 dx integration 2x will come. 4 x dx integration x square by 2 will come. Limit will from 2 to 6. Let's keep the upper limit. The upper limit, if I keep it, the 2 into 6 plus 4 and 2, the 2 into 6 squared. This is the upper limit minus lower limit 2 into 2 plus 2 into 2 square, right? Just simplify it, है ना? 2 into 6 12 plus 36 into 2 72 minus how much minus 2 into 2 4 and 4 into 2 8 will come, right? 8 plus 4 12, 12 gone. So what we are getting our answer? 6 joule we are getting. So here the force was given variable, so that's why we have used this thing to find out the work done. Okay, let's take a little bit different example of variable force. Okay, if force is given to us like this: x y I cap plus y square, or let's say 3y square j cap. You see that here the force is variable in which direction? I cap as well as j cap, है ना? Last example I took, there I took the force as a variable only in one direction, which was the x direction. So if only variable in x direction, so f dot dx is enough. But here what happened? The force is variable in I cap as well as j cap. This is the force given to us. Okay, a particle move from initial point to final point following a straight line. Okay, particle move from one point to another point, one point to another point, another point, along which line? Along x plus y equal to 10. Understood? So particle initial point is something, final point is something, and it goes to other point. If initial point is, let's say, 0 comma 10, and final point is, let's say, 2 comma 8, then find work done by the force. Do you understand the question? Find work done by the force in the question. Please tell me, understand the question? Here, how do you solve it? If force become variable in x and y, both of them, how do I calculate the work done now? Please tell me. Initial point and final point is given to us, and how particle goes from initial to final point, that is also given in the question to us. Okay, please tell me. How much is that coming? Trying this one or not? Please tell me. How do we calculate that one? See, if we want to calculate the work done here, what we should do, here the force is variable. Again, what we should do, we should first write it small work done. F dot, अब here force is x and y, मतलब I cap and j cap both. So I cannot write it f dot dx or f dot dy. I should write it f dot ds. So if I write it, I will write it xy I cap plus 3y square j cap, and ds means the displacement. So when the particle will move from one coordinate to another coordinate following this path, right? Its x coordinate will change. Let's call it dx I cap. Y coordinate will change. Let's call it dy j cap. So as the force is in x and y both the direction, so displacement also I have to take it in x and y both the direction. Now if you write it, you will get it xy plus 3y square dy. That is work done. What is the total work done process? You are doing the integration, you will find the first integrate y dx. Here, so no problem. It can be easily integrated. But here, y dx, our integration is with respect to dx. So what is the y doing? Nothing, no help. So that's why in the question it is given how the particle goes from one point to another point. It goes following the path x plus 10. In 6 in place of y I will write what 10 minus x. So if two variables are there in the integration, that integration cannot be done. But can I convert a two variable into a single variable? Yes, and only for that purpose this path is given to us in the problem, that what path the particle is following to go from one point to another point. So what is the y? Y can be written as minus x dx plus 3y square dy. Now it is a simple integration for us. Let's put the limit before integrating. X lower limit 0, x upper limit 2. X limit will go 0. Y lower limit 10, upper limit 8. The y integral from 10 to 8. Now this integration can be done. Tell me first term x 10 dx. So 10 x dx, x square by 2 minus x square dx, x square dx, x cube by 3. Limit will be from 0 to 2 plus 3. Limit will be from 10 to 8. Simplify it. 10 and 2. This one will become 5. Let's keep the upper limit. The 5 into 2 square minus 2 cube by 3. 0 if you put it 0 0 0 it will become minus 3 3 get cancelled. 8 cube. What is 8 cube? 8 into 8 64 and another 8 512. Just check the calculation once. And 10 cube means right now 8 into 8 64 into 8. Yeah, 512 we have, right? 8 cube we have 512. Now just simplify a little bit and we'll get our answer. The 4 into 5 20 minus 8 by 3. 2 into 2 into 2. 8 by 3 and 512 minus 1000. Minus will come. How much minus it is coming? That will come 500, 488 will come, right? This one just addition subtraction be possible that we may get the negative or the positive work done. To understand how to calculate the work done by variable force, then you can just do it f dx. If force is changing only in y, f dy. If force is changing in both x and y, both I cap j cap both, then you have to do it f dot ds, and ds you will write it as dx I cap plus dy j cap, and then with the dx and dy you have to do two integration. And if x and y is mixed with each other, then you try to convert it into what? A single variable before doing the integration. So where the integration is happening with dx, keep everything in x. Where integration is with dy, keep everything with y. Understand? So this is what given to us in the question. Let's discuss one last example using the graphical method to calculate the y. Done. Okay. So in a graphical method, what happened? There is a question given. that a graph is given between force versus displacement like this. This is what given to us up to this. Okay, this is given to us 50 Newton. This is 0. This is 4, right? And this is given to us as 6. This is given 8, right? And not 8. Let's take it something other value so that we'll calculate that one. Let's take this value as something 7. Okay, this value is how much? You can calculate using the similar triangle, isn't it? So this is given to us as 2. The 2 to 4, and this is 50. The 4 to 6, that is also minus 50 given to us. Okay. Find the force work done by the force from 0 to 7 meter. This is 7 given to us. So please tell me, simple question, just needed to find out what are the area and the lower portion. Let's take that area as what? The A2. Calculate individually what is A1 and A2 coming to us, and then you can add them. A1 you will take it as positive, A2 you will take it as negative, right? Because A1 area is forming above the axis and A2 area is forming below the axis. So A1 take it as positive, A2 take it as negative, and find out both the area. Simple area is there. One shape is triangle, other shape is a simple trapezium. Find it and how much it is coming. Just tell me. So please tell me how much is this coming. Tell me. It's so simple. Just the area you need to find out in this question. Please tell me how much is coming. Hmm? Please solve now. See what is the A1 will come. Half into base is 4. Height is what? 50. So 200 by 200 it will come. We will take it as the positive. What is the A2 will come? Half sum of parallel side. The one parallel side is 3. Other parallel side is 2. है ना? 3 plus 2. See now, this parallel side is 7 minus 4. Look at that parallel side. Okay now, this parallel side is 7 minus 4, 3. And this parallel side is 7 minus 6. Oh, wait. 7 minus 6, 1. So half into sum of parallel side. And what is the height? The height is 50 here. So what is that coming to us? 4 into 50. Wow. 200 minus 100 it is coming. So what is the net work done will come? A1 plus A2. How much is that coming? 0 only coming. Check it now. A1 is positive, A2 is negative. and positive, negative, both area we got it same. So net work done by the particle, how much it will come? It will come only 0 will come in the question. So please tell me, understood this one? Now,
Yes, sir.
this last example, you try it by yourself. Okay, now this example. In this example, what is given to us? That a particle is moving, okay? A particle is moving with some velocity 10 meter per second, okay? And the mass of the particle is something, again, 5 kg given to us. This time I am taking the surface as what? The rough one. Okay, this time the surface is taken as what? The mass of the particle is given 5 kg and the surface is given as what? The rough one. And the rough surface has coefficient of friction as 0.4. So they are asking here in the question, find work done by friction force. Okay, work done by friction force before, or not before, till it comes to rest. Till it comes to rest. You know, you can solve it using the definition of what? The force, then calculating the displacement, how much time it will take, right? And doing all these things, you can calculate it the work done by friction. Or if you can apply directly the work energy theorem also, you can get the same answer with less calculation. Tell me which one you want, what you want me to use. Work energy theorem part or just the definition first? Tell you, let's use the definition first, okay? Then we next class uh, we'll discuss about the work energy theorem. Then you will see the same question can be solved with less calculation. So tell me, if it is going to come to rest, that means I should find out when it will come to rest. Normal will act, mg will act, and it's a sliding, so kinetic friction will be acting. What is the normal? Equal to mg. What is the kinetic friction? Mu into normal, which means 20. So what is the retardation here produced? Here retardation will be there, na? Because velocity is towards right and acceleration is towards left. So how much it will come? The friction force by mass, the 4 meter per second square. So how much distance it will travel before coming to rest? Can we find out? So final velocity 0, initial velocity 10 squared, 2 retardation -4, and displacement. So what is the displacement we are getting? 100 by how much distance before coming to rest? 100 by 8 meter. Can we find the work done by friction then? The work done by kinetic friction, how much it will come? The friction force. How much is the friction force? 20. What is the displacement? 100 by 8 is that 180 degree. Why? Because particle displacement is happening in this direction and friction force is acting in this direction. Isn't it? The friction and displacement are in the opposite direction. So angle between them will be 180 degree. So how much is that coming? If we simplify it, 8, that will become 2.5, 100 and 2.5. So 220, sorry, 250 it will come, and minus 250 joule will come. So what is the work done by kinetic friction in this question? Minus 250 joule. You could have avoided all these calculation and directly using the work energy theorem also you could have got the same answer of minus 250 joule as the work done by kinetic friction. But please tell me, do you understand the definition of the work done? How do we calculate it? Sometimes we have to calculate the force, we have to calculate the displacement, then we have to take the dot product, to get the total work done. So please tell me, understood what we discussed now today,
Yes, sir.
right? So let's meet it on Wednesday now, है ना? And we'll continue with the work energy theorem. What is the kinetic energy, potential energy, and how to write the work energy theorem. Okay,
Okay, sir. Thank you, sir.
right, Sharon? Thank you so much. Let's meet it on the Wednesday now.